Basic proportionality theorem, that is Thales theorem. If a line is drawn parallel to one side of the triangle to intersecting the other two sides in the distinct points, then the other two sides are divided in the same ratio. Given a triangle ABC which DG is parallel to BC and D is intersects at AB in D and AC in E, to prove AD by DB is equal to AE by AC. AD by DB is equal to AE by AC. We should prove. Construction. Join BE and CD and draw a perpendicular line to AB. This AB, draw EF and a perpendicular line to AC. This is AC. We should draw a perpendicular line to DG. Now prove. From EAD, it is a triangle EAD, and EDB, this is another triangle. From these two triangles here, EF is perpendicular. This EF is perpendicular to AB and this triangle and ADE triangle. Its height for both triangles EAD and EBD. EF is height. Now the area of EAD, this triangle is equal to base into height. Base is AD into height is EF. 1 by 2 base into height, AD into EF. And area of EDB, the base is DB and height is EF. Therefore, area of EAD is equal to 1 by 2 into base into height, that equal to 1 by 2 into DB into EF. From this is 1 by 2 into AD into EF, and area of EDB equal to 1 by 2 into DB into EF. Dividing this both areas, we will get 1 by 2 AD by EF by 1 by 2 DB by EF. The 1 by 2 cancelled, EF cancelled, AD by DB. This is equation number 1. Similarly, ADE area and DCE area, this triangle area and ADE triangle area equal to, we will get the same. The area of this one is 1 by 2 into the base is AE and height is DG. So 1 by 2 into AE into DG, and area of this triangle is, the base is CE, 1 by 2 into CE into height is DG. That DG cancelled, and we will get AE by EC. Equation, this is number 2. From 1 and 2, the areas of ADE, EAD and the area of EDB and ECD. But here ADE is same in the equation 1 and 2, and DEB triangle, DEC triangle, there is a common side DE is there, so it is between two parallel lines, so its area must be equal. Therefore 1 and 2 are equal. DEB and ECD are the same base DE and same base DE, and between the same parallel lines DE and BC. So we have the area of these two triangles is equal to 1 equal to 2. So 1 and 2 we will get AD by DB is equal to AE by EC. This is the theorem number 1. Theorem number 2. If a line divides two sides of a triangle in the same ratio, then the line is parallel to the third side. If a line divides same ratio, that means AD and DB is equal to AE by EC, divides in the same ratio, this line is parallel to BC. Given a triangle ABC in which a line DE drawn such that AD by DB is equal to AE by EC. To prove that DE is parallel to BC. Proof. If possible, let us assume that DE is not parallel to BC. Then there must be another line through D parallel to BC. Now assume that DF, this is another line, this is parallel to BC. Assume that. Now let DF and BC are parallel. BC, DF are parallel. Then by basic proportionality theorem we have AD by DB is equal to AF by FC. AD by DB is equal to AF by FC. So this is equation number 1. But already given, that is AD by DB is equal to AE by EC. This is given. So 1 and 2 we have AD by DB equal to AF by FC and AD by DB equal to AE by EC. From 1 and 2 we can write AF by FC is equal to AE by EC. If we add plus 1 to this, and both sides we should add AF plus AF by FC plus 1, AE by EC plus 1, and taking LCM AF plus FC by FC and EC into 1 EC, AE plus EC by EC. But we know that AF plus FC is equal to AC, and AE plus EC is equal to total AC. So AC by FC and AC by EC. AC cancelled, then FC equal to BC. Therefore FC equal to AC means F must be coincides with E. Then DE is parallel to BC. This is the formula, theorem number 2. Theorem number 3. In two triangles, if the triangles are equal, then the sides opposite to the equal angles are in the same ratio, are proportional, and hence the two triangles are similar. Now let us take two triangles ABC, another one DEF. These two triangles are there. In triangles ABC and DEF, the angle A, angle D is equal, already given. The opposite to the angles are the same ratio. The sides are same ratio, BC and PQ, also EF. Now, then angle B equal to angle E, angle C is equal to angle F. This is given. Now we have to prove that AB by DE is equal to BC by EF and AC by DF. Construction. Locate the points P and Q. P and Q. That is DE and DF are respectively. D and DE and DF. Locate the 2 points on DE and DF where P and Q are there. You join these 2 points such that AB equal to DP, AB equal to DP, and AC is equal to DQ. Join PQ. Now prove that triangle ABC is congruent to DPQ. This DPQ triangle and ABC triangles are congruent because the sides, all sides are equal. This gives angle B is equal to angle B is equal to angle P, angle B is equal to angle P, and C is equal to angle Q also. But angle B is equal to angle P means, and E also same because these two lines are parallel. This corresponding angles makes equal. B equal to angle P is equal to angle E, and PQ is parallel to EF. P comma Q and also Q comma F are corresponding angles. This angle and Q and F are corresponding angles which are equal, then PQ is parallel to EF. Then we can write from DPT theorem dP by PE is equal to dQ by QF. This is DPT theorem. dP by PE is equal to dQ by QF. But we know that dP is equal to, we can write dP is AB because these two triangles are congruent. The sides are equal. AB by DE. Theorem number 4. If in two triangles the sides of one triangle are proportional to the side of the other triangle, then their corresponding angles are equal and hence the triangles are similar. These are the two triangles ABC and DEF. Given triangle ABC and DEF are such that AB by DE and BC by EF, CA by FD. To prove angle A equal to angle D, angle B equal to angle E, Angle C is equal to angle F. Construction. Now take DEF, because it is less than 1 means this is the bigger triangle and smaller one. And now locate the points P and Q on DE and DF respectively, such that AB equal to DE, AB equal to DP, and AC equal to DQ, join PQ. These two are ABC and DPQ are congruent triangles. From this given, AB by DE is equal to CA by FT. AB by DE is equal to CA by FT. So from this, but we know that AB is equal to DP. So you should write AB equal to DP, and CA is equal to DQ. So CA equal to DQ. Then AB equal to DP means DP by DE, and CA equal to DQ, substituting DEQ by DF from construction, and change denominators into numerator. DE by DQ is equal to DF by DQ. DE by DP is equal to DF by DQ. So subtract from this minus 1. DE minus DE by DQ, DP minus 1, DF by DQ minus 1. Then take LCM. DE minus DP by DQ and DF minus DQ by DQ. But DE minus DP is P, and DF minus DQ is QF. So we can write EP by DP, QF or FQ by DQ. Therefore, change again denominator into numerator. DP by PE is equal to DQ by QF. This means PQ divides DE and DF in the same ratio are given. So that is PQ is parallel to EF. Then PQ is parallel to EF. P and Q are divides in the same ratio, so PQ and EF are parallel. And P angle E are corresponding angles. PQ and EF are parallel. ED is transversal here. It is transversal. This ED is transversal to this PQ and EF. So we can write this DP by DE is equal to DQ by DF is equal to PQ by EF. In triangle DPQ, triangle DEF, corresponding angles are equal. So the ratio of corresponding sides also equal. Then DP by D equal to DQ by DF and BC by EF. That PQ is equal to BC. PQ is equal to BC. This PQ is equal to BC because ABC and DPQ are congruent figures. Therefore, BC equal to PQ. Triangle ABC is equal to is because triangle ABC and DPQ are congruent triangles. So, angle A equal to angle D, angle B is equal to angle E, and angle C equal to angle F. Corresponding parts of the congruent triangles are equal. 8.5. If one angle of a triangle is equal to one angle of the other triangle and the sides including these angles are proportional, then the two triangles are similar. Given in triangle ABC and DEF, AB by D is equal to AC by DF, where angle A and D are same. Required to prove that ABC and EF are similar triangles. Now construction. Here ABC is a triangle and DEF is another triangle. Locate the points P and Q on DE and DF and join this PQ such that AB is equal to DB, AB equal to DB and AC equal to DQ, join PQ. Proof: PQ is parallel to EF and triangle ABC is congruent to DPQ. From the side AB equal to PQ DP and AC equal to DQ and BC equal to PQ. Side similarity. And angle A equal to angle D, then angle B is equal to angle B, angle C is equal to angle Q. Because sides are equal, the angles also equal. Then these two figures AD, ABC and DEF also, the angle E and angle B, angle F and angle C are equal. So the corresponding angles are equal. Then this ABC and DPQ is congruent triangles. Then angle DPQ, triangle DPQ and DEF also are similar because the both DPQ triangle and DEF triangle, the common angle is D. Theorem 8.6. The ratio of the areas of two similar triangles is equal to the ratio of the squares of their corresponding sides. Given triangle ABC and triangle DEF are similar. ABC and DEF are similar. From this, AB by DE equal to BC by EF and AC by DF. The ratios of corresponding sides are equal. Also, angle A is equal to D, angle B is equal to E, angle C is equal to angle F. The corresponding angles also equal. To prove area of triangle ABC and area of triangle DEF is equal to AB square sides by, like AB by DE, AB square by DE square is equal to BC square by EF square and AC square by DF square. We should prove. Construction. Draw. AP is a perpendicular line to BC, and DQ is perpendicular line to EF. This is DQ is perpendicular line to DF. This is construction. Proof. The area of ABC equal to 1 by 2 into base into height. 1 by 2, base is BC and height is AP. So area of triangle ABC equal to 1 by 2 BC into AP. And the second one, DE, area of DEF is equal to 1 by 2 into base into height. Base is EF and height is DQ. 1 by 2 EF into DQ. The dividing area of triangle ABC and DEF we will get. So 1 by 2 into BC into AP, this one, and 1 by 2 into EF into DQ, this one. So 1 by 2 cancelled. BC by EF into AP by DQ. This is number 1. From 1, this is number 1. Angle 1 is 90 degrees. Angle 2 is here 90 degrees. And angle 3, angle 4 are same. This is angle corollary. So APB and DQE, these two triangles are similar. So AB by DE is equal to AP by DQ, that equal to BP by EQ, we can write. The corresponding sides are, ratio of the corresponding sides are same, AB by DE and AP by DQ and BP by EQ. From this, the ratio of corresponding sides of two similar triangles are equal. So AB by DE and AB by DQ. This is number 2. ABDE, ABDQ. ABDE, ABDQ. This is number 2. AB by D equal to also BC by EF is there. AB by D equal to BC by EF is there. So this is number 4. Number 3, BC by EF. This is number. From 1 and 2 and 3, AP by DQ is equal to BC by EF, we can write, because AB by D equal to AP by DQ, AB by DQ, D is equal to BC by EF. From 2 and 3, we can write AP by DQ equal to BC by EF. Substituting this AP by DQ from 4 in 1, AP by DQ is equal to, in the equation 1, AP by DQ is equal to BC by EF is equal to A into AP by DQ. The value of AP by DQ substitute in this. The area of triangle ABC by area of triangle DF equal to BC by EF into BC by EF, that is BC square by EF square. So this equal to AB, the area of, and similarly area of ABC and DF is equal to AB square by DE square and AC square by DF square. And similarly also we get AB square by DE square is equal to BC square by EF square and AC square by DF square. Hence it is proved. 8.7 theorem. If a perpendicular is drawn from the vertex of the right angle of the right triangle to the hypotenuse, then the triangles on both sides of the perpendicular are similar to the whole triangles and to each other. Proof: ABC is a right angle at B. This is right angle at B, and let BD is a perpendicular line to hypotenuse AC in ADB triangle and ABC triangles where angle A is common, and angle BDA is 90 degrees, CBA is also 90 degrees construction. So triangle ADB equal to is similar to triangle ABC because the angle criterion. So similarly angle BDC, the here angle is 90 degrees, and angle ABC here angle is 90 degrees, and C is common angle to both. So these two triangles also similar because here is 90 degrees is there and common angle is there. Two angles are common. So these two triangles BDC and ABC triangle are similar. So from 1 and 2, this 1 and 2 triangles on both sides of perpendicular BD are similar to the whole triangle ABC. Also, since triangle ADB is similar to ABC and BDC is similar to ABC. So from these two we can write ADB is similar to BDC. This leads to the 8.7 theorem. Pythagoras theorem, Baudian theorem. 8.8. In a right-angled triangle, the square of lengths of the hypotenuse is equal to the sum of the squares of lengths of the other two sides. It's Baudian theorem. That given a triangle ABC, right angled at B, this is right angled triangle at B. To prove AC square is equal to AB square plus BC square. Construction: draw BD is perpendicular to AC. Proof: In triangle ADB and triangle ABC, the angle A is common to ADB and ABC. So ADB angle equal to ABC angle, that equal to 90 degrees. ADB and ABC angles 90 degrees. So angle are colored. So we can write these two triangles are similar. ADB and ABC triangles. By this we can write AD by AB is equal to AB by AC. The corresponding sides of a similar triangles are proportional. So AD by AB is equal to AB by AC, and taking denominators into numerators, AD into AC equal to AB into AB. So AB square is equal to AD into AC. This is number 1. And from second triangle BDC and from ABC, we can write DC by BC is equal to BC by AC. So this is equal to BC square, BC into BC square, DC into AC. So this is equal to, for number 1, AB square equal to AD into AC and BC square equal to AC into DC. From these two, by adding 1 and 2, we get AB square plus BC square. AB square plus BC square is equal to AD into AC plus DC into AC. So AC is common, and AD plus CD, we know that AD plus CD equal to AC. So AC into AC, that equal to AC square. Therefore AC square is equal to AB square plus BC square. This is Pythagoras theorem. 8.9 Converse of Pythagoras theorem. In a triangle, if the squares of the lengths of one side is equal to the sum of the squares of the lengths of other two sides, the angle opposite to the first side is a right angled and the triangle is right angled triangle. So what is given? A triangle ABC such that AB square plus BC square is equal to AC square given. AB square plus BC square is equal to AC square. To prove ABC triangle is a right angled triangle. It is a right angled triangle. Construction. Construct a triangle PQR with right angle at Q such that PQ is equal to AB and QR is equal to BC. And PQ is equal to AB, QR is equal to BC. Prove in PQR, Q is 90 degrees. So PQ square is equal to PQ square plus QR square is equal to PR square. This is from Pythagoras theorem. From this, AB square plus BC square is equal to AC square. but AC square is AC equal to PQ. Then substitute the value AC equal to PQ, that is AB square plus BC square is equal to PR square, because PQ is equal to AB and QR is equal to BC and AC equal to PR. From this, AB square plus BC square is equal to AC square, because PR is equal to AC. It is given. It is given. From 2 and 3. This 2 and 3, PR square is equal to AC square. So PR equal to AC. PR is equal to AC. Sides. From ABC and ABC, the triangle ABC and triangle PQ are congruent because all sides are equal. When the sides are equal, automatically the angles also equal. Angle B is equal to angle Q. B is equal to angle Q, that is 90 degrees. And so ABC is a right angle triangle.